right? In our last sessions, I think we had a very clear discussion up to some basic chapters. Sir, today I will take only few minutes because I'm full much tired today. Okay, please try to understand. So already we completed first chapter, algorithms and analysis of algorithms, and what are the various approaches are there to solve the problems. And even we discussed about the sample algorithms and its implementations, data structures which are existed in Python, list and array programs, matrices, recursion, and then backtracking. Up to this we covered. Now in today's session, we are going to talk about ninth chapter, which is nothing but dynamic programming. Sir, it is a very simple and easy chapter. Maybe some 2 or 3 problems will be there. Beyond that, nothing. Sir, it is also a part of recursion. That's why recursion, backtracking, and the dynamic programming we are going to cover at a stretch. So, what is mean by dynamic programming? So, do you know we have some problems are there with recursion? Okay, there are some problems are there. So, if the data is keep on executing, okay, if the data is keep on executing, then it is a definitely problematic situation, right? I mean recursive calls. I'm talking about recursive calls. There are some situations where some repetition calculations will be happened in the case of recursion. We are calling that as overlapping. To optimize that, we are going for dynamic programming. Okay, optimization, optimization. Okay, optimization in recursion is a dynamic programming. Is dynamic programming. So for not for all problems we are going to apply dynamic programming. Only for a few problems we can apply. Okay, we can't apply this for all the problems. We can apply only for few problems. What are the few problems? The problems which are giving overlapping calculations. Overlapping calculations. Sir, what is mean by overlapping calculations? If a calculation is already done in the recursive call itself, if we are trying to calculate again, then such type of calculations are called as overlapping calculations. I will show you with example. So in such cases, to reduce that overlapping calculations, we are going for this dynamic programming. Okay, sir, here we are going to store. Okay, we are storing the results. We are storing the results in a array, in a array or list. So here in Python we don't have arrays, right? That's why we are going to store the data in a list. In the recursion itself, we are going to whatever calculations that you have done, you are going to put it into a list. So that what is the advantage? Next time if you are supposed to calculate the same value, instead of taking that result, sorry, instead of recalculating again, if that value is already existed in your list, you can able to get that. That is the advantage. Okay, means what? Reuse the already calculated, reuse the already calculated solutions for sub problems. For sub problems we are going to use here. This is nothing but the biggest advantage what we have in our dynamic programming. And do you know this dynamic programming we can implement in two ways? One is nothing but memoization. One is nothing but memoization, or I can say top down approach. Okay, or we can say it is nothing but top down approach. Sir, second one, tabulation. Tabulation. We are going to maintain a tabulation by using bottom up approach. Bottom up approach. The technique which we are using in this memoization is nothing but recursion, and the technique what we are using in the tabulation is nothing but loops concept. By using this, we are going to reduce the instructions. Anyway, I will show you how it is going to be calculated by taking some examples. Then only you can able to understand this problem very clearly. Okay, only 3 points I covered, sir. What is the first point? When we have to go for dynamic programming, if in your program, recursion based program, if you are keep on calculating the values again and again, means already calculated thing, again if you are trying to calculate, which will create the biggest problem. To overcome that problem, that problems are called as overlapping calculation problems. To overcome that problem, what we are going to do, we are going for either memoization or tabulation. In both cases, we are going to reduce the number of problems what we are going to get. Apart from that, nothing is there in this dynamic programming. Sir, if your outline structure is very clear for you people, I will start implementing this program. Can you please confirm everyone, is the concept is clear for you people, so that I will start the application number 1. Can you please tell me, is the concept is clear? Please confirm. Sir, you people are there in the session or not? Please confirm everyone, is the concept is clear?
Yes, sir.
Yes, sir.
Right. So what we are doing here, what we are doing here, very simple. The first application here is nothing but we have Fibonacci numbers is there. You know the sequence, right? What is mean by Fibonacci sequence? Initially we have two numbers are there, 0 and 1, and next number is calculated by adding by adding previous two numbers. That's all right. First I will implement this by using recursion. Okay, so implementation of FIB sequence with recursion. First we will try to solve this problem by using recursion. Sir, here I'm going to take Python program to solve this problem. Observe carefully. Sir, I want to define a function. Already we know this very well. Fibonacci n. If your n value is equal to 0, or if your n value is equal to 1, then we are going to return the value of n. Otherwise, we are going to return FIB of n minus 1 plus FIB of n minus 2. That's all. Simple calculation we are doing. Okay. Suppose consider I am trying to call Fibonacci of the number 5 or 6, something like this. So try to execute this code, and what output we are going to get here, you can see we are getting 8 as the output. Okay, 8 is nothing but my output. That we know very well. But sir, what is the problem with this recursive implementation? We are going to discuss now. Have a look once. Sir, in this example, if you see clearly, first we are trying to call Fibonacci of which number? 6. Please listen carefully. Fibonacci of 6. Since it is not equal to 0 and it is not equal to 1, it will calculate a Fibonacci of n minus 1 and n minus 2. That means internally it is divided into two parts. What is the first one? Fibonacci of 6 minus 1, 5. Fibonacci of 6 minus 2, 4. And this 5 is again calculated with the two steps. Fibonacci of 4 we are going to get, Fibonacci of 3. And this one is calculated into two parts. Fibonacci of 4 minus 1, 3. Fibonacci of 4 minus 2, 2. And this 4 is again calculated with the Fibonacci of 3 and then Fibonacci of 2. This 3 is calculated Fibonacci of 2 and Fibonacci of 1. And this 3 is calculated Fibonacci of 2 and Fibonacci of 1. And this 2 is calculated as a Fibonacci of 1 and Fibonacci of 0. And this 2 is calculated Fibonacci of 1 and Fibonacci of 0. This 2 is calculated Fibonacci of 1 and Fibonacci of 0. and same this one Fibonacci of and Fibonacci of 0, and this one Fibonacci of 2 and Fibonacci of 1, and this one Fibonacci of 1 and Fibonacci of 0. Have you remembered here how many times we are calculating Fibonacci of 3? If you see, this is the first time, this is the second time, this is the third time. Unnecessarily 3 times we are calculating. Sir, how many times we are calculating Fibonacci of 2? This is the first time, this is the second time, this is the third time, this is the fourth time, this is the fifth time. Have you observed? 5 times. But the result is same. But result is the same. Unnecessary calculations are increasing. This concept is called as overlapping. Overlapping. If you want, you can see I am declaring one global variable with count is equal to 0, and I will print in a formatted string saying, so number of calculations, okay, number of calculations which is done is nothing but C. So whenever the recursion call is started, I am incrementing that count by 1 unit. Whenever recursion call got started, I am incrementing that count by 1 unit. Now see what will happen here. I am trying to run the program. How many calculations has been done? It is going to display. How many calculations? The total Fibonacci of this 625 calculations. If you want, you can cross check. Is it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 calculations has been done. Sir, can I reduce this? Yes. That is the reason why we are going for this dynamic programming. Why we are going for this dynamic programming. In the dynamic programming, we are trying to reduce these calls, sir. So in how many ways we can implement a dynamic programming? By using memoization or by using tabulation. First, I will explain by using memoization of this particular program, and then we will go for tabulation. I request everyone to please confirm, is this concept why we need to go for this dynamic programming? Is it clear, right? Please confirm, friends.
Yes, sir.
Yes, sir, clear. Yes, sir.
Someone is asking, sir, overlapping. Yeah, you can see, right, Ram? Right. Sir, now what we are going to do here? What we are doing here? Sir, implementation of a Fibonacci sequence with, which one, sir? Memoization. Okay. Let us see how you can able to do this. Sir, program is the same. I will do some small modification. Listen carefully. I will create a list, sir, with none as a default elements. How many numbers you are going to generate? Maximum 10 or 15, something like that. Okay, let it be 100. So I created a list with how many objects? 100 objects. All the 100 objects are none. Now see here, before here global C and C is equal to C plus 1. First we are going to check. Array, you are calling Fibonacci of 6. I will check whether that Fibonacci of 6 is not equal to none. Not equal to none means what? In that list, that sixth Fibonacci number is there. Array, why you need to calculate? Can you please return that L of n? That's all. Suppose if it is not there, then check whether your number is 0 or 1. If it is 0 or 1, try to store in the list with that index as n. So otherwise what we are going to do? That L of n will become L of, no, we have to call Fibonacci of n minus 1. So plus Fibonacci of n minus 2. Okay. Then we are going to return L of n. Beyond that, nothing is there. Anyway, I will show you how it is going to work. Listen carefully. I think in this example, we are not required to create 100 elements. So I have a list with, just for example sake, so none, 2 elements, so 3 elements, 4 elements, 5 elements, 6 elements, like this I am taking. Locations 0, 1, 2, okay, so 3, 4, 5, I think 6 also is required. Let it be none, 6th location. Now listen carefully. Please understand very clearly, sir. So I called Fibonacci of 6. Okay, I called Fibonacci of 6. So what it is going to do? It is trying to calculate 6th Fibonacci. First, it will check if L of 6 is not equal to none. No, it is equal to none. That means the calculation is not yet done. Is n value is equal to 0 or 1? No. Then this Fibonacci of 6 is we are calculating L of n. L of 6 we are calculating, which is nothing but FIB of n minus 1. FIB of 6 minus 1 is nothing but what? 5. FIB of 6 minus 2 is nothing but 4. And it is calculating for f of 5, sir. So it will be calculated for f of 4 and f of 3. Okay. And it will be calculated for f of 3 and f of 2. Okay. And it will be calculated for and it is again calculated for so f of 2 and f of 1, and it is again calculated for f of 1 and f of 0. Please listen carefully the returned values. Sir, when n is equal to 1, L of 1 is equal to 1. So L of 1 is nothing but what we are assigning to 1. So it will return 1. L of 0 will be assigned to 0 and it is going to return. Now f of 2 is returned here. So what will happen? F of 2 is nothing but the previous two numbers. Some 1 plus 0 will become 1. Okay, f of 2 is nothing but 1, 1. And f of 3 is nothing but f of 2. F of 2 value is what? 1. And f of 3, just now we calculated previous two values sum, which is nothing but f of 1. Have you observed? Here f of 1, we are not required to calculate. Already that value is there. So hence f of 3 will become what? 2. Now to get f of 4, listen carefully. We need f of 3 and f of 2. F of 3 value is already available. F of 2 value is also already available. We are not required to calculate. Now what will happen? 2 plus 1, 3. So f of 3 value. Look into the table. That value is already there, right? So again, why you need to calculate that f of 3 value is already calculated? Try to reuse. 3 plus 2 will become 5. So f of 5 will become 5. F of 4. Already here somewhere we calculated. Try to take that value. 5 plus 3 will become 8 is the answer. Correct, right? Yes. And this value is updated to 8. Have you observed? Sir, how many calculations we have done here if you count? So in this example, you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 calculations. But in the previous case, I think somewhere we got 25 calculations. Here what we are doing, we are using recursion only, but we are trying to store the calculated value from the bottom. Okay, so that you can able to reuse if anywhere that the calculations are required. I think you people got a very clear clarity how we can able to use this memoization only to reduce the number of comparisons, number of calculations. We are using this memoization, sir. Beyond that, nothing. I request everyone to please confirm, friends. Is the concept is clear for you people?
Sir, in the first line, instead of 100, we can just take the length of the n, right?
We can reduce the length of the n, no problem. If you want, you can
Yeah.
fix that value also. Since I have given 6 here, I think we
You
have
can
to
just
take
take.
7, right?
Okay.
Is it 6? 6 is not sufficient, right? We have to give 7 because we are counting from 0th location. You can count 1, 2, 3, 4, 5, 6, 7 elements are
6.
there.
Okay.
You have to count from 0 because you know
It'll be length of
index
n
count.
plus 1.
Right. So
Okay.
you can take. Otherwise, if you are reading the value of n dynamically from the user, since 14, 15, 16 lines are global, you can write it in the first line, no problem. Or first
Okay.
you can read the value of n and then you can initialize L, then you can call the function.
Yeah. Okay.
If we want to Ankit Sharma, no problem. You can put this 15th line in a loop, sir. Okay, you can put that loop fib of 6 in a loop.
Okay, sir.
Right. Yeah, time will be reduced, that the calculations is going to be reduced. Nothing more than that. So next one, this Fibonacci sequence implementation by using tabulation we have to do with tabulation technique. Nothing, sir. Here we are using loops. It is very simple. We have to write a proper loop for this. That's all. Okay. I think here no need to calculate the number of things. Okay. Here we are going to declare one new one in the function itself. I am going to define one new dp an array or a list with how many elements we have seen already, n plus 1. Now dp of 0th location we know 0, dp of first location we know 1. Then for each I value in the range of starting from 2 to n plus 1, because already 2 numbers we have taken. Now your dp of n will become what? dp of I minus 1, dp of I minus 1 plus dp of I minus 2. Since it is a list, we are not making any recursive calls. Automatically it will be calculated. And at last we are going to return dp of n, something like a looping concept, sir. So we have taken a list, in that we are trying to store all the values by calculating. And once if you calculation got completed up to n, and we are trying to return that last number what we calculated. That's all. And can I run this program? Yes, definitely it will return. Oh, we are getting 32. Is it correct?
Sir, actually, I minus 1 you have taken twice.
I minus 1 I have taken. Here I think we have to take I minus 1 or I minus 2, I minus 1. Can I take like this?
Yes, sir.
Yeah, let me check. Yes. Here no need to count the number of calculations, because how many times it will be executed? N minus 2 times, because if your n value is 6, 6 minus 2, 4 times the loop is going to execute. Okay. So here we are not required to calculate any time. Even if you calculate, you can't take the statement in the fib, because it is not recursion, right? So loop how many times will execute plus those two instructions will give that a total number of times it is going to calculate. Okay, nothing is there, sir, more than this. I hope this tabulation method is very clear. Just I have taken a simple example where overlapping will come and how you can able to solve this problem. Sir, is the concept is clear how we are going to use this backtracking? Please confirm everyone.
Yes, sir.
Yes, sir.
Right. So I think I provided only basics for you. So that's all about today's session. I will stop now. Maybe tomorrow I will explain one or two programs which is related to this dynamic programming, where overlapping will come and how you can able to reduce that overlapping. With that, our things will be done. Okay, our things will be done. I mean, dynamic programming is going to be completed. Okay, maybe maximum tomorrow we will see that program, and after completion of that, we will go for rest of the things. Right? Any queries?
No, sir. But other than that question, I have one Python question. May I share you with, please?
Yeah.
Okay, sir.
Already you have shared.
Yes, yes. Actually, in the group I have shared. Can I ping in once again?
Which problem, sir? I think because my schedule is full busy, sir. That is the reason I was unable to see those things.
Sir, could you please wait for a 1 minute only? I
One
will
second.
share it
In
in
our
the chat
group,
box.
it is already there.
Pardon me?
In group already you have shared.
Yes, 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 yes. I have shared in the group.
Something like 1 in 1 or 11, that is 1 in 1 plus 1 into 2 question mark 1 plus 3 question mark. Yeah, you have typed this. Do you have any copy of this
Sir, I will
problem
explain
statement?
you. I will explain you in the short format only, sir.
Hmm.
Sir, actually, in that problem, what I need to.
1 second, 1 second, sir. 1 second.
Okay.
So, no chapter for list. Who is that? No, already we have covered that list in the data structures. Okay. And that list related programs also we have covered. Okay. In the data structures, we have seen strings, list, tuple, everything, right? And yeah, that's all about today's session. Tomorrow we will go for this dynamic programming, another 1 or 2 examples. Later I will start more maximum strings. Okay. Yeah. So with this, the session got completed. Remaining people, if you want, you can stay. Otherwise, you can leave because some doubt is there. I will try to clarify that.
Okay.
Yeah. For example, if the input is 1.
Sir, the question marks are the spaces only.
Okay.
So, I can share with you. I will tell you that, sir. 11 into 2. What will
11
be the
into 2.
Yes.
Okay.
Then space is there.
Okay.
Then 1 plus 3. Space is there. Then into 7.
Okay.
Space is there. Like that, you have to continue, sir. Question mark. Question mark in the sense is this is the space. Then
Okay.
double plus sign. Then 8, 7, 9.
8, 8, 7, 9. What is this
Yes.
actually?
Sir, actually, what is happening here is that like 11 into 2 is 22, right?
Okay.
Then 1 plus 3 is 4.
Okay.
Yes.
1
So,
plus 3 is
sorry.
1 plus 3 is 4.
Yes, yes, yes.
So 22 space 4.
Yes, yes, yes.
Okay. Then
Wait, sir, wait. Wait. So there is an explanation in the chat actually. Shall I copy here so we can easily
yeah.
get an idea about it? Sir, I have pasted in the chat box.
The first print should return the result of calculation 11 into 2, 22. Okay. Then the program received the characters 1 plus 3. Yes, 1 plus 3. So the result should be 11 into 21. 11 into 21 plus 3. So the result should be
Sir, means we cannot consider space here. 11 into 2. Then next is the integer, right? So
Hmm.
2 and 1. C is 21, I think so. So 11 into
Okay.
21 plus 3. Is the
okay.
answer is
We
the
got to
231.
231. Okay. 231. The next character is into 7. The result should be 1121 plus 3 into 7. Okay. And the last preceding character plus plus, they could not be interpreted as a error should appear. And the characters 8 7 should not be processed. Okay. Okay. So this one you need it as a output.
Yes, sir. Sir, when double operator signs were there, we must have to get error there. But whenever the integers will be there, that integers
First,
get blank.
let us give the proper input for this. I think it is 11. Okay,
Into
let us rewrite this. So 11 can I take like this and into 2, and here space is there.
so space can be neglected, sir.
Yes, we
So
have to
it is
ignore the
21
space.
then.
It should become 21. And
Yes.
here also it should be neglected. It should become 3 into 7. And while neglecting here, we got two places. So it is invalid, right?
Yes, yes. So, sir, in the output, they given the output like that 11 and 2, 21. If you are multiplying that plus 3, you will get the 234 answer over there.
Okay.
Yes. Then
So
again, you can
into
say
7.
multiply by 7.
If you multiply that 234 into 7, is it 252? I think so. No. I think first these two got multiplied. For that, this 3 into 7 got multiplied. That will be added. I think so, if I'm not wrong.
Yes, yes, yes.
11 into 21, I think so. If I apply shortcut 2 1 2 plus 1 3 231, I think so. It may be okay. We will see that. I think so. It is.
Sir, like
Yeah.
here, sir, whenever integers are coming continuously, we have to clamp that integers, and whenever the in between the operators were there, the accordingly the output will be there.
Okay, okay. Sir, where you got this question, sir?
Sir, actually, one interviewer asked the question. My
Okay.
friend is in the USA right now. He is
Okay, okay.
one
Okay.
interviewer
I
asking.
think we have to use strings and regular expressions, sir, to solve this. I think so.
Yes, sir. I tried it a lot, but I haven't got an output over there.
Okay, okay.
Yes, sir. Here only 11 into 22. Sorry, 21 plus 3 into 7. But next time there is a double operator plus sign.
So
So
we have to return
we have
error
to
message.
return the error.
So after error, nothing has to be printed.
Yes, it should not be processed further. Sir,
Yeah, we
I
can
need
do that.
idea
I think
about
so.
only that, sir, how we can neglect that spaces, and if like that, sir, in the line number 6631, there is a like question mark is there, right? Or I can say where one, then there is a space and there is again one. So integer followed by integer gets clamped as an 11, right? So next element is operator. So if the operator is there, accordingly it should be multiplied or plus or divide, whatever it is. So here multiplication is there, so that's why it's got multiplied, and it is the
Okay, sir.
answer.
I got the problem statement clearly.
Yes.
We will see, sir. I need some time to do this. because it is related to the regular expressions we have to use. You need to check the operators and we have to remove the spaces and we need to calculation part also is there. I will check it, sir. Once I will check it, I will get it, I will inform. Okay.
Sure, sir. Sure, sure.
And the remaining students, those who are in the sessions, you can try. If it is working, then it will be helpful. Okay. Right.
Thank you, sir.
Yeah. And this problem will be there in the bottom of our running notes. You can check if anyone wants to try. Yeah, right. Tomorrow we will meet for the continuation with a few more problems in our dynamic programming, sir. Right. Thank you.
Okay, sir. Thank you.